This video is going to show you how to determine if a set of data has proportional relationships, like in the table, or if a graph is also proportional based on the points that have been plotted. The first thing we need to review is how can you tell if a set of numbers would be proportional. So proportional in general means that the numbers that are in this set are going to increase or decrease by the same amount each time when you look at each data point. Another way of saying this is that it will have a constant rate of change. We're going to look at a real example. The data has been put into a table, but the table is not complete. So in order for us to finish and do what the direction says, we have to fill in these 3 empty spots. Again, the directions say complete each table and then explain why the relationship is proportional. So they're already telling us in the directions that it is going to change at the same rate. If you look at the information they give you, it says this person earns $8 per hour. So for however many hours they work, we are going to multiply by 8. If you look at this first example in the table, they've completed it all the way. They said the person worked 2 hours, so they would earn $16. If you look in the next space, it says the person is going to work 4 hours, but the spot underneath it is blank. So we need to determine how many dollars they would earn. If they work 4 hours, and I'm going to multiply that times $8. That should be 32. So now I'm going to fill in the table, and I'm going to write 32. Because that's the answer we just got when we multiplied the time in hours times the pay per hour. The next 2 boxes are a little bit tricky because we don't know how many hours they worked. We only know how much money the person earned. So in this instance, we're going to have to work backwards in order to find out how many hours they worked. If the person earned $40 and I know that they're getting $8 per hour, I'm trying to figure out what times 8 is 40. Those numbers are pretty small and they work together fairly well. But when you get to harder questions, if you don't know, we need to work backwards. So in order to do that, I would divide 8 into 40. And 8 divided by 40 is 5. So in my table, right above 40, I could fill in this box with the 5 that we got from the division problem. Then the last box has $72, but I don't know how many hours the person worked. So I'm going to set this up the same way. I don't know how many hours the person worked, but I know they're going to get $8 per hour. And the question tells me that they already earned $72 total dollars. For this question, again, we're going to have to work backwards. If you already know something times 8 is 72, you could fill it in. If not, working backwards means we need to divide. 8 divided into 72. And 8 times 9 is a perfect match for 72. So now I know that the person worked 9 hours. My table is complete. That was the first step in the directions. The next step says explain why is this proportional. Before in class we've talked about taking all of these numbers and creating a fraction or a ratio and then dividing. We could do that, but they're already telling us right here in the directions that the cashier gets $8 per hour. So that's basically what I'm going to write for my description. I'm just going to put the cashier earns $8 for each hour worked. And then I would be done with that problem. If it didn't tell me this information at the top, again, we would make fractions or ratios and divide. So the first one has a 16 and a 2. 16 divided by 2 is 8. If we look at the second one, we have 4 and 32. 32 divided by 4 is also 8. And then I would just keep going. But since the question already told me this at the beginning, that's what I can put as my reason. I don't have to do all the dividing. Okay, I know this says example 3, but I'm skipping example 2. So if you're in my math class, we're going to move on down to question 3, where there is a graph made but no table. And the direction says tell whether the relationship is proportional. And then we have to explain. So I am going to tell yes or no, is it proportional? And then explain why. There's 2 different ways that we can solve this question. We could make our own table and then put them together, or we can look at the dots and connect them. So I am going to look at the dots and connect them, and then I'm going to put it into a table. So my first point, if I have my table, I have time on the x-axis, and I have distance on the y-axis. So this is our x-axis, this is our y-axis. I'm going to fill in the information based on where the points are on the graph. So when we look back at this first one, on the x-axis, when I drew my line straight down, it matched with 1. So my first x value is a 1. If I go up to the dot and then go sideways to the y-axis, it perfectly lines up with 40. So my first distance is 40. When I think about what this means, it means 1 hour lets me go 40 miles. So I'm just going to keep doing this. The next one, if I draw a line straight down, that's in between 1 and 2. So that number would be 1.5. If I draw my line straight over to the side on the y-axis, that number is between 40 and 80. So between 40 and 80 would be 60. So I'd put 60 there. Check the next point in the graph. If you draw a line straight down, that matches up with 3. And we want to go to the y-axis. I'm going to draw a straight line sideways. That matches up with 120. So that lets me know if I go 3 hours, I would make it 120 miles. And there's one more dot in the graph. I'm going to draw a line straight down. It matched up with 4 on the x-axis. When you go straight down, matches 4. And then if I draw a line straight sideways, that matches up with 160. So I'm going to add that to my table. Once we have our table, we are going to create our fraction and ratio, divide, and see if we get the same answer every time. So if I look at my table, my first values are 1 and 40. So I'm going to say 40 divided by 1. Anything divided by 1 is itself, so I already know that one's going to be 40. The next set of numbers in the table is 1.5 and 60. So I'm going to say 60 divided by 1.5. I do not know what this equals, so I'm going to have to actually work it out. I'm going to do it over here on the side and then shrink it. 1.5 divided into 60. We've already talked about dividing decimals before, and we said the number on the outside should be a whole number. So in order to do that, we need to move the decimal 1 space to the end, and I need to change this number the same way. Move the decimal 1 space to the end. Okay. If I keep dividing for this, I'm going to say 15 cannot go into 6. It can go into 60. And I just happen to know that that's going to be a 4. That's 0 left over. I got to bring down this next digit. 15 can go into 0 0 times. So that answer is also 40. Okay, we got 2 more to look at. The next set of numbers are 3 and 120. So I'm going to do those over here. 120 divided by 3. Let me erase it. 3 can go into 12 4 times, and then 3 cannot go into 0, so I'll put a 0. So far, I've gotten 40, 40, and 40. So I'm looking pretty good. The last set of numbers is 4 and 160. So I'm going to divide those. 160 divided by 4. And if I think about this in my brain, 4 can go into 16 4 times. 4 can go into 0 0 times. So again, I got a 40. If we look back at the directions to see what does it really want me to write on these lines as my answer, it says, tell whether the relationship is proportional. That means I should answer this by saying yes or no. If I look back, I got 40, 40, 40, 40. All the numbers are the same, so I would say yes, it's proportional because it is increasing by 40 each time. So let me see if I can make all those words smaller. It's increasing by 40 each time. Let's see if those will get smaller too. Perfect. And that's how you would solve a problem that starts as a graph. A good idea is to make your own table and then see if it increases the same every time. Okay, we're going to look at another example. This one is still a graph. When you look at the directions, it says, tell whether the relationship is proportional, explain. So again, I'm looking for yes or no, are these dots proportional? There's no table, so I'm going to create one. On the x-axis, it says age, so I'm going to put that in. And on the y-axis, it says height of the tree, so I'm just going to say height. Again, in order to make our table, we're going to look at each one of these data points. We're going to draw lines going down and sideways to see what does it line up with on the x-axis, what does it line up on the y-axis, and then at the end, we'll determine if they're the same. So the first dot, if you were to draw a line straight down, that matches with 1. On the x, if you draw a line straight sideways, that matches with 40. If we go to the second data point, I draw a line straight down. That matches with 2. I draw a line straight across. That is actually between 40 and 60. So the number between there would be 50. The third dot, if I draw a line going straight down, that matches with 4. If I draw a line going straight sideways, again, that's in between two numbers. It's in between 60 and 80. So that would be 70. The last data point, if I draw a line straight down, it matches with 5 on the x-axis. If I draw a line straight sideways, it matches with 80 on the y-axis. So now in order for me to say if this is proportional or not, I need to take each set of numbers, create a ratio or a fraction, and divide to see what I get. The first set has a 1 and a 40. So I'm going to make 40 divided by 1. 40 divided by 1 would be 40. If I look at the next set of numbers, it's a 2 and a 50. So I would say 50 divided by 2. That equals 25. Half of 50 is 25. I really do not need to keep going at this point because my first answer was 40, my second answer was 25, so I already know it is not going to be the same answer every time. So I can stop. I don't need to divide anymore. And on this question, I would say no, it's not proportional. And I'm going to shrink that. Actually, I'll leave it the same. It's not proportional because it does not change by the same number. If you have another way of saying that that's shorter, you can definitely do it in your own words. Congratulations, we've made it to the end of the video. We've had one example where a table was created. We had 2 examples where there was a graph that we started from and made our own table. So now, hopefully you can apply these steps or processes to determine if something is proportional on your own homework problems.